We've already learned about some of the ways the periodic table is organized. For example, periods, which are the horizontal rows, tell us how many electron shells an atom of each element has. Groups or families of elements, which are in the vertical columns, also have similar properties to each other. Finally, there is this crazy zigzag line that kind of stair-steps down the table that separates metals from nonmetals. But what does that really mean? What are metals? What are nonmetals? What are these mysterious properties that they share? Let's start with metals. Some of these properties will have really fancy science names, but once I describe them to you, will probably seem really familiar, especially once you hear some of the examples. Hopefully, the examples I give will make it really easy for you to remember these properties of metals by name. First is the property of luster. Metals have luster. Luster is just a fancy word for being shiny. Lustrous metals reflect light really well, giving them a shiny appearance. Gold is a metal that is very lustrous. This is one property that makes it so popular as a material for jewelry. Ooh, shiny. Ooh, lustrous. Next is conductivity. Metals are very conductive. This means that they let electricity pass through them easily. Copper is a metal that is very conductive. It is often used in electrical wiring. This metal allows electricity to quickly travel from the power plant to your home and then to whatever you have plugged into the wall. Thank you, conductivity. Without you, I couldn't watch my favorite team win on Saturday. Related to conductivity is another property of metals called ductility. When a material is ductile, it can be made into wire easily. Metals are ductile. Copper is a metal that is also very ductile. That's why it can be made into wire so easily. Another physical property of metals is malleability. In order to be malleable, a material must be easily bent or shaped without breaking. Sometimes metals are shaped using lots of force, like with a hammer. And sometimes they are so malleable, they can be shaped using just your hands. Think of aluminum foil. This metal can be shaped using just your hands, and it doesn't shatter. Yay, leftover pizza. Finally, compared to nonmetals, metals have a high density. Remember, density is how massive something is for its volume. Simply put, metals are heavy for their size. Think about this. If I were to make a marble out of iron, which is a pretty dense metal, it would be much heavier than the glass or plastic marbles, both nonmetals, that you normally see. Now for the nonmetals. Basically, all of their physical properties are opposite of metal properties. But of course, we need to use some fancy words to describe them. So here we go. First, nonmetals are dull, and I don't mean their personalities. I mean that they do not reflect light very well and are therefore not shiny. An example of a nonmetal being dull is charcoal, which is made of mostly carbon, a nonmetal. Charcoal is not shiny. It is very dull. Nonmetals are also opposite from metals in that they do not conduct electricity well. This means that electricity does not easily or quickly pass through them. Another word for this non-conductivity is insulation. Nonmetals are good insulators. Think about what surrounds the metal wiring you plug into the wall from our earlier example. Materials like rubber, a non-metal insulator, surround lots of metal wires. This keeps us from getting electrocuted every time we plug in our phones to charge. Thank goodness. Finally, nonmetals are brittle compared to metals. This is the opposite of malleability. Being brittle means that nonmetals are not easy to bend without breaking or shattering. An example of this is glass, which is made of mostly silicon and oxygen, both nonmetals. In its solid form, glass cannot bend without shattering. It's very brittle. So let's review. Metals are to the left of the zigzag line on the periodic table, and they share some really important physical properties. Some examples of metals are gold, copper, aluminum, and iron. These metals are lustrous, can conduct electricity, and are ductile, malleable, and dense. Nonmetals are to the right of the zigzag line on the periodic table, and they share some really important physical properties too. Some examples of nonmetals are carbon, hydrogen, and oxygen. These elements make things that are dull, do not conduct electricity well, meaning that they are good insulators, and are brittle. Now, let's take some time to guess whether materials are metals or nonmetals based on their properties.